Hey everyone, hope you guys are having a good first virtual day at home, and we'll see how these lectures treat you guys. Try to keep them short, and hopefully you learn something today. So today we're going to go over something called dimensional analysis. Okay? And all dimensional analysis is just a fancy word to say we're going to work on unit conversions. Okay, so how do we convert from one unit to another? And I'm going to show you a method, and this is really a method to how to keep track of your units when you're converting between units. So before we start dimensional analysis, we want to take a look at something real quick, and we want to take a look at how do units act, okay, while you're doing conversions. And the big thing here is units are like variables in math. Alright, what do I mean by that is this. Let's say we have x. Okay, so say we have an x variable. Let's say I take x and I multiply it by x. Well, that's going to give me what? It's going to give me x squared. Okay? So just like variables, if I had a unit now, let's say I had centimeters, and I multiply it by centimeters, that's going to get me centimeters squared. The same thing is true if you're doing other mathematical operations such as division. So say I had an x cubed term, I divide it by an x term. What's going to happen is that cubed is going to cancel out to a squared, and this x is going to cancel, and I would get x squared. Again, the same thing is true with units. Let's say I take centimeters, and I have centimeters squared divided by centimeters. Well, this centimeter is going to cancel out with that square term, and I will be left just with centimeters. So what we're going to do today as we do dimensional analysis is we're going to learn a way to keep track of our units, okay? But we're going to remember, hey, our units are going to act just like variables do in math. So the method we're going to use, or I'm going to want you to use, is called the railroad method, or the train track method, some people call it. So let's just call it the train track method. And the reason it's called the train track method is when you set it up, it kind of looks like a train track. So I think the best way to do this is let's just go ahead and do an example problem. So let's convert 5 inches to millimeters. Right? Now, in order to do this, we've got to have some conversion factors, right? I can't just make up numbers to go from inches to millimeters, but here are some things that I know. I know that 1 inch is equal to 2.54 centimeters. Okay, that's going to get me from standard to metric. And then I also know that 1 centimeter is going to equal 10 millimeters. So now I have a way to get from centimeters to millimeters, sorry. So let's take a look at what we do. So when you're doing this method, you always want to start, okay, anytime you do unit conversion, you always want to start with the value given. So in this case, I'm given 5 inches. So I want to start with 5 inches, and I'm going to put that up top here. And then I'm going to draw my train tracks. Okay, now my train tracks are like a fraction. Okay, so in the top we have the numerator, and the bottom we have the denominator. And that's going to play a factor because remember, our units act like variables. So if I'm multiplying across the top, you know, if these values are all here in the numerator, I'm going to multiply them. And if they're in the denominator, I'm going to divide them. All right? So let's think of what we can do here. Now, I do not want inches in my final answer. I want millimeters. All right? So I want to get rid of this inch unit. Well, how do I do that? The way I get rid of this inch unit is I need to divide by it. So I'm going to put inches down here. Okay? So I need something which I can divide inches out. Well, I come back over here and I look at my factors. Well, I know that I have a conversion factor here that 1 inch is equal to 2.54 centimeters. So I have a way to get from inches to centimeters. So I'm going to put centimeters up top here. Then my inches would cancel out. And now my units would be left in centimeters. And again, they're going to cancel out because units work like variables, and now I have something in the numerator and I have inches in the denominator. So they're going to cancel each other out. So now I'm in centimeters, which is good because now I'm in the metric system, but I want my answer to be in millimeters, all right? So I want something else here. So I know I want to cancel out centimeters, okay? And over here I've got another conversion factor. Hey, I know that 1 centimeter is equal to 10 millimeters, so I'm going to put millimeters up top here. My centimeters are going to cancel. And then my only units left are millimeters, which is good because what did I want? I wanted millimeters as my answer. Okay, now I'm going to go back and plug in these values. Sometimes I've found that's helpful if you just look at the units first before you put in the values. Well, I know that in every 1 inch, there's 2.54 centimeters. I know that there are 10 millimeters in every 1 centimeter. So now I've added my values back here to my conversion factors. So then what's left is just now the arithmetic. Okay, I have millimeters left, which is what I want. All my other units have canceled out. So now I'm going to take 5. I'm going to multiply it. You can think of these as kind of like parentheses. Sometimes people would write it like this, 5 inches. And then you multiply 2.54 centimeters per 1 inch. And then you could do 10 millimeters divided by 1 centimeter. Okay. If that helps you see the arithmetic here. Okay, so I'm going to multiply across this numerator just like I would do with any fractions. So I take 5 times 2.54 times 10, and what I find out is that gives me a value of 127 millimeters. And that's going to be my answer. Let's take another look. Let's do another example problem here. Okay. So now what I want to do is I want to convert 144 inches squared, or squared inches, to square millimeters, or millimeters squared. And again, I'm just sticking with the same units here, so we're not too worried about conversion factors. I still know the same conversion factors. I know that every 1 inch is equal to 2.54 centimeters, and I know that there are 1 centimeter is equal to 10 millimeters. Now these conversion factors you have to know. Okay, so they'll either be given to you or they're known quantities. Like this is known. I didn't make this up. 2.54 centimeters is equal to 1 inch. That's my conversion factor. Okay, so let's take a look at this. So let's start with the value we have. We know here's our measurement. We know we have 144 inches squared, or square inches. Okay, so it's always going to go in my top left there on my railroad tracks. The value given in the problem is always going to go up there. All right, now what else do I know? I know I need to get rid of inches squared here, so I'm going to put inches in the bottom. Okay, because my conversion factor is inches. I know that I can go from inches to centimeters. All right, so again, units act like variables. So my inch is going to cancel here, but the problem up here is this isn't just inches. Inches what? It's inches squared. So just like if I were to have x squared divided by x, that x would cancel out with that square term, and I'd have 1x left. The same thing is true if I have inches squared divided by inches. The inches cancel out the square term, but I still have an inch term left. Okay, so I come back up here and look. Alright, well I need to do something again. I still have an inch term up in my numerator, and I don't want that. The squared term is gone. So I'm going to do the same conversion factor again. I know I need inches in the bottom again to cancel out with this inch term. And I know how to go to centimeters from inches. Okay, so I've gotten rid of both my inch squared terms by doing this conversion factor twice, and now I have 2 centimeter terms. Well, I know I want to get rid of those because I want to go to millimeters squared. So I'm going to put centimeters in the bottom and go to millimeters. So that one's going to cancel with that term. But now I have centimeters times millimeters. Well, my units, I don't want centimeters times millimeters as my units. I want millimeters squared. So I need to get rid of this centimeter term. Well, in order to do that, I need to do centimeters in the bottom. So I'm going to put millimeters up top again. And this centimeter is going to cancel with that centimeter. Okay. Again, if it was a cube term, I need to do it one more time. But again, variables and units act the same. So if I got inch squared, I need to do this conversion factor twice. All right, so then I'm going to plug this values in. I know there's 2.54 centimeters per 1 inch, 2.54 centimeters per 1 inch, 10 millimeters per 1 centimeter, and again 10 millimeters per 1 centimeter. So then I'm going to multiply across the top. 144 times 2.54 times 2.54 times 10 times 10. And what that comes out to be is 92,903 millimeters squared. There's your answer. Alright, so I hope that was helpful. Introduction to dimensional analysis. This railroad track method is really going to help clean up your units and keep track of them. Okay, so we always want to start with the value given in the top left here, and then we're going to cancel out our units using conversion factors until we get to the final units we want. If it's a squared term and your conversion factor is not squared, well then you'll just need to use that term twice. All right. So don't forget to like, subscribe, and have a great day.